extremely well, threading everything about Java. So come back to this slide if you're a C developer and you want to get into Java. These videos from Stanford are amazing. Now now that you know Java, you have to learn Android. And the good people at Americana have put a $3,000 course online, and you can go and view these videos online, and they will go through every step of designing Android. So in the next couple slides, I'm going to drive deep into Android, but I'm showing you how to learn this. And Google has great tutorials, and they have great documents. If you follow these slides, you're going to learn Android. Okay, iPhone. iPhone is built on Objective-C. It was a predecessor to C++, so there's a lot of oddities about Objective-C. You're absolutely fine to take an object and cast it to another object and call a method on that object that does not exist. So in Objective-C, you can say I have an object of a fish, and I'm going to cast it to a car, and I'm going to tell that car to go swimming. The compiler will not say there's any problems. I've talked to a lot of language designers, and they cringe at Objective-C. But it's how we do iPhone development. It's coming along. I've heard the language has some more advancements in it. But I'm going to show you some Objective-C. It'll make you really think about it. But I'm going to show you how to learn it. So Stanford has a fantastic class you can get through iTunes or YouTube, and they go through C and C++. And they have another class, CS170, that teaches all the internals of how stacks work, pointers, all that stuff. So you learn those. And then they have another class that teaches iPhone. And I have not found any better resource on the internet to learn iPhone than Paul Haggerty's Stanford class, CS193P. He actually worked at Netscape and helped design Objective-C. He knows Objective-C extremely well. And then you have the Apple developer documents and the tutorials. So way to learn Android, because I'm going to show you a change in embedded development. You're going to do Android. You're going to learn iOS. It's just how we're going to do embedded development. And the last thing you're going to have to learn is HTML5. And the reason you have to learn HTML5 is because it is becoming the language that most of us speak. In fact, if you want to do Google Glass development, you're going to be developing in HTML5. So for embedded developers, I don't know how you guys feel about web programming. I'm sure a lot of you guys hate the DOM model, and JavaScript is kind of crazy, but it's where we're going. So learn Android, learn Objective-C, learn the iPhone, learn HTML5, CSS, JavaScript. So on this slide, I cover how to learn JavaScript. The JavaScript was written in 10 days at Netscape. Man, anytime you write a language in 10 days, it's going to be crazy. And JavaScript is an insane language. Now, these slides will teach you JavaScript, but I'm going to drop really low really quick. If you make a variable and you don't put the var keyword on there, it's mapped to window. So what happens is sometimes you're calling that variable and it works, and sometimes you call it and it doesn't work. And all you did is you forgot to put the word var in front of your variable. So JavaScript is really cumbersome. Hopefully these slides, what I'm showing you, will help you find the resources you need to learn JavaScript really well. And I'm telling you, I know we're embedded developers, but like I said, if you even want to program for Glass, you're going to do JavaScript, HTML5. JavaScript is the most used language in the world. We're not going to get away from this fact. But there are fantastic libraries out there to use. AngularJS, jQuery, it hides the DOM and it hides the JavaScript, so we can actually get some work done. Now, I'm going to be talking a lot about moving away from deep embedded development to using Android, iOS, HTML5 to build things that we used to do on the embedded world. And I have to say that sometimes you're going to build it in Android, sometimes you're going to build it on iOS, sometimes you have to build it on both. But the way you're first going to start to build it is you're going to build it on HTML5 with JavaScript and CSS. And then you're going to use either JCap, Titanium, or Corona to run it on your mobile device. Because the fastest way to build for a mobile device today is to use one of these platforms, JCap, Titanium, or Corona. You just mock it up in HTML5. You do your JavaScript for your logic, and what you will find is that you can deploy it to the cell phone extremely rapidly. And if you need to, then you can go to a native development environment, right? So the best way to build on a mobile platform to get started with is to do web development. What happens is these platforms, PhoneGap, Titanium, Corona, they have a web view, and they all run on WebKit. You render on that. They take that web view and they compile it to a native application. So you can sell these in the stores as native apps. It is HTML5, it is JavaScript, but it compiles to a native app. You can put it on the store, and you can start making money, right? Okay, so now we're all Android experts, we're all iPhone experts, we're all web programmers. The reason I believe over the last 7 years I've been coming here and I'm watching a transition from people building embedded to building mobile is because the sensors are amazingly powerful. Right? I mean, if there's enough sensors in the phone that it can tell you when you're angry or sad, there's a lot of sensors. And I'm going to be giving you some crazy examples of what people are doing on the mobile front. But there's a huge problem with sensors. They're noisy, and you get garbage out of them. So when you're doing your mobile development, when you start talking to the accelerometer or the gyroscope, you kind of get like unusable data out of them. But the new operating systems, they have these software sensors, and they have very, very complex algorithms, well understood algorithms, but still extremely complex algorithms that make these sensors usable. So there are various types of sensors. The first ones I'm going to talk about are the motion sensors. Unless the phone's moving, you get zero out of these guys. So the hardware sensor is the accelerometer. Now, if you have your phone and you drop it, the accelerometer actually shows there has been no acceleration. And you're like, wait a minute, that doesn't make any sense. I just took my phone and I dropped it. How could the accelerometer tell me there's no acceleration? It's because it has gravity built into it. So, again, the hardware sensors, they don't really give you what you think you're going to get. We have another hardware sensor, which is gravity. And we take the gravity sensor and the accelerometer sensor, and we make a software sensor that is linear acceleration. And this is actually what you want, because you start calling the linear acceleration, and you see numbers that make sense. And again, we have the gyroscope, which works off the Coriolis effect, and it gives really weird numbers when you start working on it. But you want to use the rotational vector. And when you use this sensor, it makes sense. And so I just saved you guys a lot of days because I find that a lot of people try to use the hardware sensors. Unusable. You have to use high-pass filters to clean it up, and then you have to use low-pass filters to get out a certain bandwidth, and then you have to use all this complex math. We've come a long ways from the early days. We have really good software sensors. So that is for when the phone is in motion. The motion sensors will tell you what's going on. The position sensors, if the phone's not working, they still give you numbers, like the magnetic field. That's a hardware sensor, so therefore it's going to give you garbage. Because the magnetic field, like if you go, I want to know north, it's going to show you magnetic north. And the magnetic sensor, it's next to a freaking motor and other electronics, and you're just getting garbage out of it. But what you want to use is the orientation sensor. The orientation sensor actually filters all that stuff out and gives you the orientation of the phone. And this is really important for augmented reality, because if you're holding your phone like this, the augmented reality system has to know you're looking forward, and if you point it up to the sky, it has to know, look, I'm not looking at anything in the viewing planning area. So a lot of augmented reality has to do with orientation of the phone, and you get orientation even if you're not moving the phone. So motion, phone's got to be moving. Orientation, it's just the orientation of the phone. Not only do you get all of this information about your motion and your orientation, but it gives you lots of environmental sensors. So we have relative humidity, ambient light, proximity sensors, and at first they kind of sound cheesy, like what am I going to do with relative humidity? What am I going to do with ambient light? But they're super powerful, and people are very creative the way they use them. ambient light, they actually have an application where I can have my mom run this application, and if she's not turning off and on the lights, it alerts me like, hey, it's nighttime and I'm not seeing any change in lights. Better call her. Did she fall down? Did something happen? So they look like cheesy sensors, but when you get into the heart of them, people are doing some really amazing things with these environmental sensors. And then there's another section that I call capture sensors. So on the cell phone, these things can see, they can hear, and they can feel. They got a camera so they can see, they have microphones so they can hear, and they have touch screens so they can feel. So with all these sensors, it's absolutely amazing. We're getting devices that are almost self-aware. And this is the trend I'm seeing from people developing on mobile to who were developing on embedded. Now that we're all Android experts, I just want to talk a little bit about how you use the sensors on Android. If you're going to go learn Android, this will come back to you. But basically, super simple. Super simple to use the sensors on Android. All you do is you call the sensor manager. The sensor manager gives you the system sensor manager, and then you tell it what type of sensor you want. Here I said accelerometer because I'm an idiot and I'm going to use a hardware sensor. Should have used a software sensor because this guy's just going to give you total garbage. Once I get my sensor, so if you know Android or you learn it, what you learn is an activity is a view. So you have this view. When you bring up that view, what you're going to do is you're going to do a sensor listener. And that sensor listener is going to talk to the sensor manager. And every time an on-sensor changed, you're going to get notified. Super simple code, very easy to work with. You just put your code that you want, that's called, like say, I want to know my linear acceleration in the x-axis. You just put your code in the sensor event listener, and it'll be executed, and you can tell your acceleration. So I just want to point out with this slide, it's very simple to do. On the iPhone, again, we have a very nice library, a framework, Core Motion. And Core Motion, you can use it to get all the information about linear acceleration and your gyroscope and position. Again, the frameworks and the libraries that are in place make our lives very easy. Google did a fantastic job with their sensor manager. Apple did a fantastic job with their Core Motion. It takes all the noise out of the sensors and makes it really easy for us to work with. So on the Android phone, you saw the sensor manager. So you just call the sensor manager and you listen for events. On the iPhone, this is Objective-C. I don't know if you saw Objective-C anymore, but it's out there. So view did load. That's when my GUI has come up. And these open brackets, these are how you call an object and call a method. So I'm calling the CM Motion Manager. I'm calling that object and I'm passing it Alec and it. And anytime you see Alec, you see init right after it. So now I have created that object. This dot notation for gyrate update interval, that is I have synthesized that property and I'm calling that property. I'm setting it. And I'm checking another property to see if my gyroscope is available. Now if you guys don't know Objective-C, that's fine. I showed you how to learn it. We can come back to these slides and go, okay, now I understand what he's talking about. Sorry. I didn't. So what you see in the next line is iOS, for their threading, have these things called blocks. So if you see Objective-C code and you see a little hat, see that little hat up there? This funny little thing? That's an iOS thread. Crazy. It's a block of code that's going to be put on a queue and it's going to be accessed at a certain rate. So here what we're saying in this code is, hi Mr. Motion Manager, I want the gyro to update me at this interval, and when you update at this interval, this is the block of code I want you to run. Right here, that's the block of code. Now if we ask the Motion Manager, do you exist? And he says, I do not, then we simply disable the button that says it does not exist. Again, Objective-C. You saw Java, you make a new object, you call a method. Objective-C, very different. You use these brackets to call it. So, Objective-C code, yikes, right? We have an IB action. An IB action is something that so Objective-C works in a controller view model. This code is in the controller. And when the view calls the controller, what happens is it sends an IB action to the controller saying that something in the view has been done. So what we see in this code is that the sensor, this ID sender, this is the button, the UI button is the sender, and he has sent something, and we're going to read his current title. And if it's start, then what we're going to do is we're going to send a message to Motion Manager. So this is the object I'm going to call, and the method name here in Objective-C is actually fragmented, right? So in Java, you would say Object Motion Manager, call a method, and here are the parameters. In Objective-C, it's fragmented through it. So what you see is this is the object, and the method name is start gyroscope update to queue with handler. So you see that in Objective-C, the method call and the arguments are interspersed with each other, right? It's very unusual, but that's how Objective-C does it. So this is the method, start gyro update with handler, and the arguments are OPQ gyro handler. So that's how you make a method call in Objective-C. And here we can see if the button is started, it starts up. Okay. So now we have seen how to do Android. We've learned Android. We've seen how to do Objective-C. We've gone through the sensors. One last thing. How do you do HTML5? So in HTML5, you write a bit of JavaScript that is going to add an event listener to the window. And here we're going to say we want the device orientation. And I believe I can show you a demo. So this is a bit of JavaScript running. Oops, sorry. And as you can see, it's reading my device orientation, and the JavaScript is running in the browser, and the browser is talking to the sensor and transforming the information, right? So now in the browser, I'm talking to sensors. All right. So let's go back. How did that work? JavaScript. JavaScript is a higher order functional programming language, i.e. you send and receive functions as variables. So what you're seeing here is my first variable is I want to tell I'm listening for the device orientation. My second variable is a program, right? So again, it's a higher order functional programming language. So here's my second variable, the function which takes an event. And what it does is it takes the event alpha, beta, gamma, and it passes it to this function that I'm passing in as the second parameter. And then this false tells it if I want to capture this event going down or coming up the hierarchy tree. Again, JavaScript. I showed you all the links to learn it. You can go back there and you can learn about how it's a higher order functional language. How does it work? Very cool thing that you can do in HTML5. Let's see if I can do this demo. Hi there, how are you doing? Hey there, how are you doing? Phenomenal voice to text. And it's one line of HTML. So when you're doing your mobile development, right? This is so cool. Right? You now have an ability to put voice to text with one line of HTML5 in all your applications. Then this piece of this HTML text box has an ID, and in JavaScript, all you do is you get that ID and you say get text, right? Super easy. HTML5 makes it absolutely wonderful to be able to work with these sensors. Okay, so now we have learned Android. We have learned iPhone programming. We have learned web programming. We're geniuses. It's a good day. What does this all mean, right? Being able to be an Android developer or an iOS developer, building on these platforms that allow you to do mobile and web and convert it into a native application. We can gather tons and tons of information. Now, I just want to talk a little bit about how you get that information from the phone, from those sensors, out to whatever devices you need to get them to. On Android, you use the Java net, so it looks just like a socket. HTML5 has these things called WebSockets, and iOS use NS streams. So now we gathered our information from the sensors, and now we can communicate it out to the world. There's two really, really amazing things that are on most cell phones. The first is NFC. Near-field communication is probably one of the coolest, like magic technologies I've seen in a long time. I'm going to go through really quickly on how you use NFC on Android. If you take this information, and if you don't know Android, you go back to those slides, you learn Android, this is all going to make sense. Super simple. The beautiful thing about NFC on Android is if you tag something and you don't have access to the program that NFC tag needs, it will actually go to the Play Store, download that application, and start it up. It's absolutely effortless. It's duck to water. You have a tag here, you take your cell phone, you touch it. I don't care if you don't know where the application's taking you. I don't care if the application's not there. I don't care what's going on. All the right things happen like magic. It's the beautiful thing about NFC. Now, I'm going to show you how to do NFC on Android. And you're going to go, okay, well, how about NFC on HTML5 and NFC on iPhone? Because we're all iPhone, Android web developers. Unfortunately, NFC is only on Android right now, but Apple did buy an NFC company, and I expect NFC to be on iPhone very rapidly. NFC is fairly easy to do. You get an NFC manager. That NFC manager allows you to get an NFC adapter. You only have one NFC manager. Basically, an NFC manager is the hardware that reads the antenna, that modulates the electromagnetic pulse that hits the NFC tag and writes back. Maybe I jumped too fast. So NFC is a little tag. It's a little wire tag that you touch to a phone and you get information from it. To be able to talk to that tag, you write NDEF messages, and inside the NDEF messages, you have NDEF records. In Android code, you're going to see this thing that is called tag. That tag is actually the hardware device on the phone, and when you go tag.connect, it actually modulates the antenna to be able to transfer information from the phone to the tag and the tag back to the phone. So when you see the word tag, that's actually the hardware. When you go to read it, you get this NDEF adapter and you read the extra NDEF message in there. That's how you read from NFC. I just want to put this up real quick for people who are doing NFC on Android. This can save you some hours. If you have an intent that is saying I'm looking for NDEF discovered, and on the tag it actually is a tech discovered, you will touch the tag all day long and never have anything happen. Because what's happening is the tech discovered is below the NDEF discovered, and if your intent is grabbing the NDEF discovered, you're never going to see it. You're never going to get your notification. So if you're touching your Android phone to the tag constantly and nothing's happening, take your code and make the intent react to a tech discovered, and then you'll probably be able to see the message come through. Now you're probably wondering, okay, what is an NDEF record, and what's tech, and what's an activity, what's an intent? Those pages that show you how to do Android, they cover all of that. When you do NFC, come back to these slides if you're having problems trying to figure out where the messages are going. The most powerful thing about NFC is you don't have to do the Bluetooth dance. That Bluetooth dance will kill any user experience, right? So I want to pair my Google Glass with my computer. I have to put my Google Glass into this discovery mode, and I have to go to my computer, and I have to, look for the code and accept the code, and after I do the Bluetooth dance, then finally those two will connect. What NFC allows you to do is take that whole dance, put everything in that dance needs onto a card, and when you touch the two Bluetooth devices together, the NFC tag will help them do that dance and instantaneously give you a Bluetooth link. That is fantastic for a user, right? Because a user doesn't have to go into any discovery mode or any of that stuff. And by a simple touch, the Bluetooth, both Bluetooth devices are linked. It's magic. So I want to talk a little bit about Bluetooth, because when you do embedded development, 90% of the time, you have something a couple meters away from you. You need to get it into the cell phone so you can transmit the information. Bluetooth is fantastic. So Bluetooth on Android, very easy to do. You get this Bluetooth adapter. With the Bluetooth adapter, you can find all of the devices that are around you that you can link to. Then you use this Bluetooth server socket, and you ask the Bluetooth device to tell you what's around you. You get that device, and you say, hey, I want to link with you. And he sends you a socket. The server socket gives you back a socket, and you guys are now just doing TCP/IP talk, right? Bluetooth on Android, super easy to set up. And if I went too fast, I showed you all the resources you need to go figure out how that works. And now we have the coolest thing in the world, which is smart Bluetooth. No? Okay. You have the coolest thing, which is smart Bluetooth. Smart Bluetooth allows you to have a Bluetooth connection to a device, and that device can go 10 years without a battery. Because what Bluetooth, classical Bluetooth does, is it's open for a live stream. So you have this constant TCP/IP connection going between the two devices. With smart Bluetooth, it's just sending just a little bit of information once in a while. And it allows you to have like a little cell battery that's a CR2030, and it'll go for 10 years. Now, when people talk about Bluetooth Smart, they're talking about a subclass of Bluetooth 4.0. And this subclass of Bluetooth 4.0 has two modes. It has single mode and has dual mode. When people talk about smart Bluetooth, they're actually talking about a whole new technology. So when we want to put Bluetooth, classical Bluetooth, in with smart Bluetooth, then we have a dual mode device. And they call these things smart ready. So if someone's talking about a smart ready device, they're talking about their cell phone, or they're talking about their computer, which has the classical Bluetooth, and it has now the smart Bluetooth. If you have a single device mode, that's going to go for like 10 years. Because it's only going to communicate when it needs to transmit just a little bit of data. And because it doesn't have classical Bluetooth in it, it's not going to have open stream, which means that it's going to use very little power. So again, when people talk about Bluetooth Smart, single mode uses very little power, dual mode has both classical Bluetooth in it and smart smart Bluetooth. So you're going to hear the devices, you can hear the terms smart device and smart ready. And now you know how to distinguish those two. Okay, now my talk starts, right? So half an hour since I started, now I can actually talk about what I wanted to talk about, which is what I've been seeing over the last 7 years. 7 years ago, I saw car GPSs. I saw restaurant pages. I saw sleep monitors. People were making embedded sleep monitors. People were making embedded devices that were blood pressures, calorie counters, digital musics, location tracking, handheld scanners. I saw all these things. People were building them with embedded devices. Fantastic. Well, now, those are all apps on the cell phone, right? Smule is a company that uses the microphone on the cell phone and the speakers to make innovative music devices, right? Most GPS systems now are on our phones. In fact, the Android GPS system outworks my car's GPS a factor of 10 to 1. And when I go driving with my friends, they turn off the GPS in the car. They put their Android phone on the dash, and they go with the Android phone. Fundamental change, right? Fundamental change in how we're doing things. If I see somebody today designing an embedded device that is going to be some sort of tech instrument, I say, why isn't that just something Smule would do on the phone? And I can show you examples of where the embedded world is changing because of what people are doing on the cell phone. Now, that first word on that slide, it's not Nokia. I'm not saying Nokia cameras turn into a cell phone. Not Nokia, it's Nikon. Nikon, the people who make the cameras. Look at this Nikon camera. That's an Android phone. So Nikon now is starting to use as the base of their cameras a cell phone. So all of those processors they were buying, all the memory they were buying, all the operating systems they were writing, man, that's just water under the bridge. They don't have to deal with that anymore. If there's a hardware bug, if there's some problem, they have the cell phone manufacturers say, hey, you guys fix this. We're just the optics on the front end. Samsung, who does make cell phones, is now getting into cameras, right? So we're seeing this bleeding of the people who were doing embedded devices. Nikon was buying a lot of like TMS 430s, and now they're just building Android phones. We're seeing Samsung bringing their cell phones into the camera domain, right? So we're also seeing people not even augmenting the cell phone, but just adding something to it to make it something that transcends what it could be. So people are putting camera lenses on the iPhone, and what we're seeing is they're saying, you know what, you don't have to buy that Nikon, you don't have to buy that Samsung, just buy a piece of glass from us. So again, people are dropping the level of complexity they need to do to build these devices. And this example right here breaks my heart, right? So Rovio decided to build a wireless internet-equipped mobile webcam that enables you to view and interact with its environment through a streaming video, audio, wherever you are. Fantastic. You look at that thing, I was psyched. I thought, this is the coolest thing. It costs about $800. They had some problems with the hardware. They had some problems with the software. Getting all the communication devices going, it was kind of rough. I don't think it's on the market anymore. Cost $800. A lot of work went into it. Probably came to this embedded systems conference, got the hardware, tried to figure out how all the ASICs work, and built it all. Okay, Romeo. Romeo is a wireless internet-equipped mobile webcam that enables you to view and interact with its environment through streaming video and audio wherever you are. Wait a minute, that's exactly what I just read here. Wait a minute, okay. So what's this thing? Well, this thing is an iPhone, and they wrote a lot of software, very good software, that allows the iPhone to use its quad processors, its microphone, its camera, to be able to basically follow you around, react to your emotions. You can talk to it. These guys also put in a camera, processing power, Wi-Fi. The difference is, right, all they did was this product cost $149. All they did was they put some wheels on it. And by putting wheels on this thing, they made it to the main stage at TED, which is one of the premier conferences on technology, education, and what's the other one? TED. Design. Thank you. They made it to the main stage at the TED conference by putting an iPhone on some wheels, and they are now called the future of robotics. Are you kidding me? I mean, you're just kind of sitting there scratching your head. They put an iPhone on some wheels. Okay, we can do that, right? I just showed you Android, showed you how to do iPhone, showed you how to do mobile HTML5. We can take it, put it on some wheels. We could be on the TED stage going, hey, we're the future of robotics. So this kind of breaks my heart, right? I see embedded developers, and they're starting off building really complex hardware and software when they could just do this. One more example. I'm watching people build artificial intelligent Teddy Ruxpin toys. These things talk back and they communicate with you, and they have all these sensors and fairly expensive, long development cycle. Oobly took a pillow, stuck an iPhone in it, and they're selling these things for $27, and they're blowing them all out of the door. Now, the guys who are building Teddy Ruxpin AI toys, if they have a problem in hardware, right, they're not going home that night. If they have a problem with their chip manufacturer or whatever, it's absolutely a nightmare for them. These guys, their hardware's been vetted. In fact, the way that people use Ubly is they have an i3, iPhone 3, iPhone 4. They take that and they put it in the pillow and they move up to an iPhone 5. So this is a fantastic market for the old iPhones and the old iPods. Everyone's got these devices and they don't know what to do with them. These guys are like, okay, you know what? Just take it and stick it in a pillow and it becomes a toy for your kids. They're blowing the roof off. They're making sales, unbelievable sales. Now, the Teddy Ruxpin AI doll, it has a software problem. What are you going to do? You're going to recall all those things? How are you going to update that software? This thing, you go to the iOS store, right? Fundamental paradigm shift, right? If you can start off with an iPhone, Android, web-based mobile phone as the basis of your design, software updates are effortless. I'm not paying for that software update. It's automatically coming to my phone. I'll do it 10 times a day. Completely, I have no problem with software updates. So, huge paradigm shift of how we used to do embedded development, how we're doing mobile these days. And I have a store. I can upsell. So I do my Teddy Ruxpin toy, and I go ahead and I ship it to you, and you have that. I made a one-time sale. These guys have access to the iOS store. They can sell something to those kids every day. Again, huge paradigm shift here. Now you know why I ran back from Google and skipped work. I really believe there's a huge story here. Now, I'm sure a lot of you guys are thinking, oh, he's going to explain how that 90K sonogram is just a little bit better than the iPhone sonogram or the portable one. But that's not the point of the slide. I'm not going to say that the iPhone for $7,000 is, relative in comparison to something that's 44K or 90K. Not the point. I'm not going to talk about the dollars. I'm not going to talk about the size. I'm not going to talk about the portability. I'm going to talk about the acceleration of how fast the product is evolving, right? So that iPhone will have 8 cores in it by the end of next year, right? That device, that 90K device that the medical company made, embedded developer came here, figured out what he was going to, what components said he's going to put in here, goes into a long 2-year development cycle, comes out with this device. Sorry, keep touching my touchpad. Goes into a long 2-year cycle to build this thing, ships product. Got to stay in the market for 10 years to make his money back, right? That iPhone, quad processor, probably 8 core by the end in 2 years out. That the sonogram that's for $7,000, its acceleration is off the charts because it's going to evolve so much faster. So again, another huge point. So, trying to make sure I don't run too late. I got a story. So the first engineer at EA, I was talking to him. He works at Box now, and he drew on a piece of paper. He drew me a graph. He worked at Xerox PARC when the internet was just starting, and he was talking to one of the fathers of the internet. And on a piece of napkin, this guy drew the person I was talking to a graph. He goes, "This is technology and this is time." And what happens is technology grows exponentially and we think linearly. So whatever you're thinking, you're already behind. So he drew the same graph for me. This is Technology, this is time. I'm thinking linearly, it's growing exponentially. So whatever I think is going to be around the corner, I'm totally wrong. Because you know what? I'm wearing a universal translator. I can go into any country right now and talk to them, and this thing will translate to my ear exactly what they're saying, and to my ear tell me how to talk back to them. If we were to walk over to Google right now, and I could catch the right people, me and you could get into a car, it would drive us, no one's touching the steering wheel, it will drive us to downtown Mountain View, drive us around Mountain View, and bring us back, and no one will touch the steering wheel or the brake or the accelerator. I cannot imagine how fast technology is moving, right? So if we're going into long development cycles, we're going to be missing a lot of stuff. So this is something that we were thinking about. Okay, I keep preaching this idea that the cell phone is the answer. So we did this project for Red Bull, and they said, okay, make us a dispenser. There's this thing called Freestyle that Coca-Cola put out. This thing is amazing. It's got processors in it. It's got Wi-Fi access. It can talk to the home base and tell it when it needs syrup. And it can do all this stuff. Well, you know what? I can take a dumb piece of steel and put a little nozzle on it and have it talk to my cell phone and make something that is far smarter than the Freestyle dispenser that Coke made. So the way that our system works is you walk up to the dispenser and you tap it with NFC and you get a Bluetooth link to it. At that point, that device now has a Wi-Fi connection through me up to the home office and to the cloud. From my mobile app, I can look at my database of how I do my carbonation, my water, and my syrup for how I want this thing to dispense the Red Bull's drink to me. So I can change my preferences far beyond anything that multi-million-dollar Freestyle Coke dispenser can do. Because I'm leveraging the power of my cell phone. I told you guys earlier there's an app that can tell my mood. I can hold the cell phone. The cell phone can dynamically tell the Red Bull thing, I'm low on power. It can give me a little boost of caffeine. There's no way the Freestyle multi-million-dollar dispenser that Coke built can ever do that. And how much does this thing cost? Nothing. There's no internal logic in it. The screen that I'm using to tell me what's going on is on my cell phone. The communication devices are on my cell phone. The GPU, CPU is all on my cell phone. I'm talking to the cloud, right? So either I can be working for Coke and I spend $1 billion making $1 million dispenser, or I can spend a couple $100 making a cheap dispenser and use my cell phone for the GUI, for the communication, for the processing power, and yes, even knowing what my mood is. Now, you look at what I built, right? I basically took a normal dispenser. I put a little nozzle on it that controls how I'm mixing, a little more caffeine, a little bit more sugar, a little less sugar. And the beautiful thing about this is, because the UI, the communication, all of the internals, all the complexity is on my cell phone, that thing is extremely cheap to build. But that's not the point. The point is that there is absolutely no training necessary to get this thing up and running. Because all I do is I go into 7-Eleven and I plug it in, and as long as it can bring up this Bluetooth link, which it can easily do,